So StarRocks is a kind of like a new generation query engine for the data lake. It has a really simple architecture with only two kinds of processes, so FE and BE, and no external dependency, so it's easy to maintain, right? And it has an MPP computer architecture with fully vectorized execution layer, right? And it's also written in C++, so it's SIMD optimized. And so it basically incorporates every single optimization you can think of for a query engine for OLAP workloads to running complex joins and aggregation workloads, right? And also for the data lake, raw performance wise, it also has a mature built-in hierarchical caching layer, right? To basically accelerate the queries by getting rid of or minimizing the amount of data scan on the data lake, right? Which is the bottleneck of data lake queries. So its raw performance is really fast. And here we can take a look at a benchmark. This is the TBCDS 1 terabyte benchmark between StarRocks and Trino, right? And TBCDS is those kind of like really complex joins and high quantity aggregations benchmark. So it really resembles those ETL workloads, ETL queries, and those really complex ad hoc queries, right? And on this benchmark test, StarRocks is 5.5 times faster than Trino. So, and this talks about like how fast StarRocks raw performance is. But the problem we're trying to solve is not only that, right? We're trying to solve the ETL problem because on the data lake, for the scale of data on the data lake, it doesn't really matter how fast the query engine is. It still have to do on-demand pre-computation, right? And this is where StarRocks Materialized View comes in.